Now we will discuss frequency shift keying. FSK. Generally when we use carrier for transmission, BFSK. Changing parameter is frequency. Applied digital two type of levels, digital data, voltage to frequency converter. Voltage two type of levels, plus V or minus V, converted into particular frequency. Digital data available to us is 101011. We want to convert this digital data into particular line code for the purpose of FSK. Then we use binary data polar NRZ VCO FSK. 1 is represent V, 0 is represent minus V. Polar NRZ. I can draw polar NRZ V minus V, V minus V, V and V. Instantaneous frequency is FC KFMT. Instantaneous frequency FC plus KFV, FC minus KFV. Mark frequency, space frequency. We can segregate these two frequency accordingly. If one is available, we use 2 cycle of the particular carrier. For 0, 1 cycle. For 1, in FSK we draw in this way. For 0 is 1 cycle, for 1 is 2 cycle. F1 is integral multiple of 1 upon TB to maintain waveform continuity as in BASK. F2 is also integral multiple of 1 upon TB, and difference is also integral multiple of I upon TB to maintain waveform continuity. Two type of representation we use here. S1t equals to A cos 2 pi FC t. S2t equals to A cos 2 pi F. Two type of frequency we use here. Bandwidth efficiency, we introduce new parameter bandwidth efficiency rho equals to RB upon minimum bandwidth, minimum transmission bandwidth. We can calculate minimum transmission bandwidth from is frequency domain spectrum. One by TB, 1 by TB, TB. If we transmit two different frequency, means two different component aligned at particular carrier frequency, omega C1, omega C2. Difference between these two is omega C2 minus omega C1 plus this component is 1 by TB. This component is 1 by TB. Both are added for bandwidth purpose, means 2 by TB. Omega C2 minus omega C1 2 RB. Minimum, as per minimum criteria, minimum bandwidth for this is omega C1, omega C2 minus omega C1 is minimum should be RB. to maintain waveform continuity 3 RB is minimum FSK bandwidth. So the bandwidth efficiency for this is RB upon 3 RB 1 by 3. Bandwidth efficiency for FSK is 3 RB. In FSK scheme, we are transmitting two different type of frequency alternately. Those frequency are integral multiple of 1 upon TB and its difference also 1 upon TB. We can construct FSK. FSK is two interleaved ASK. It is two interleaved ASK. Two interleaved ASK is known as FSK. Both are differentiated by the frequency omega C1 and omega C2. For the constellation diagram, we can draw for FSK also. S1T is denoted by A cos omega C1T. S2T is denoted by A cos omega C2T. S1T is root of EB 2 upon TB cos 2 pi F1T. S2T is root of EB 2 upon TB cos 2 pi F2T. This is the root EB phi 1T, root EB phi 2T. Both diagrams showing in this way, both are unit energy function with multiply with EB. We know that two cosine function with different frequency harmonically related to each other are orthogonal function. To cosine function with different frequency harmonically related are orthogonal to each other. Means in the constellation diagram we can draw in this way: cos 2 ft root of 2 by tb cos 2 pi ft equals to tb sine 2 pi f1t, and negative of this tb negative cos 2 pi f1t 0. Root of EB is marked here and root of EB is marked here. We want to calculate the difference between D minimum between these two. D minimum is 2 root EB. EB plus EB and root 2 root EB is D minimum. If D minimum is mentioned as in this way, then we can say probability of error for BFSK is Q root of 2 and naught. We can solve and rewrite this expression EB upon n naught. From D minimum we can calculate probability of error for FSK. Now we will discuss PSK. Phase shift keying. In PSK, 1 for carrier, 0 for out of phase carrier. S1t equals to A cos omega c t. S2t equals to minus A cos omega c2t. Both carrier are phase difference. Block diagram of this is polar NRZ binary data. We apply product modulator here, PM or multiplier. Multiply with A cos omega ct and then BPSK. Basic idea of generation is first apply polar NRZ 1 0 0 0 1 0. For 1 it positive, for negative positive and again negative. Now we want a carrier component, multiply with. For 1 we draw 2 cycle, for 0 we draw out of phase 2 cycle, again 2 cycle, for 1 we draw 2 cycle, for 0 we draw 2 cycle. Means whenever transition come from 1 to 0, phase changeover exists. We can recollect by multiplying the same carrier in the demodulation side and use the threshold, particular threshold value, and we can get the result. In this case, Fc should be integral multiple of n upon Tb to maintain the waveform continuity. In the same case as ASK, if we want to calculate the bandwidth for PSK is bandwidth calculation. S1 is A cos omega ct. I draw S1 in this pattern, omega c. Same magnitude is reverse but occupies same bandwidth. Both are occupying same bandwidth, magnitude is reverse. So bandwidth cover is 1 upon Tb, 1 upon Tb. Total bandwidth cover is omega c plus 1 upon Tb minus omega c minus 1 upon Tb. Get difference from it, 2 upon Tb equals to twice Rb. The correct idea of PSK bandwidth is same as bandwidth of ASK and bandwidth of PSK are same. Difference is ASK following on off keying instead of off, PSK following 180 degree out of phase. If some phase error introduced in demodulation process is similar to ASK. Phase error induced, it produced at the output same amount of phase error, means quadrature null effect is effective in this case. Now we want to calculate probability of error. For probability of error we have to calculate from this formula S1 S2t square dt integration. S1t can be marked in this way: root EB 2 upon TB cos omega naught omega ct. S2t equals to root EB 2 upon TB cos with negative sign omega ct. Energy for both component is directly we can calculate a square t by 2. S2t is a square t by 2. S1t with negative sign, S1t or S2t, S2t square of it and integrate for this domain. Net power energy is upon net energy is a square 2a square t. We can put this value in directly in the formula. We get the appropriate result. Probability of error is q root ed upon 2 and naught. Error is q equals to 2a square t upon 2 and naught. If we want to calculate in term of EB is come from this term, both energy added and divided averaging by 2. It is known as bit energy. Averages by 2. Net bit energy is a square t by 2. If we put this value in it, then probability of error is now revised 2 EB upon N naught, which is 3 dB inferior. Probability of error for PSK is 3 dB superior than probability of error for ASK and probability of error for FSK, because this quantity directly relate it. Energy amount is just double, so 3 dB superior. We directly compare component between the bracket. If for ASK formula is Q EB upon N naught, or PSK formula is Q EB upon N naught, and if this term is X, this term is another X, this is 2X. Double energy means 3 dB superior. Double means directly we can relate 3 dB. We can draw constellation diagram also for PSK. S1 root EB 2 upon TB cos omega t. S2 is minus root EB 2 TB cos omega ct. If someone want to draw constellation diagram phi t, for drawing constellation diagram root EB with negative sign. For drawing constellation diagram, difference between these two is d minimum. So we can directly say d minimum is twice root EB. We can put this value into the formula. Probability of error formula is d minimum square upon n naught. Probability of error is q 2e b whole square upon 2n naught. 2n naught formula is now by solving this 2 EB upon n naught, so we can come up to formula by this method, and we can calculate threshold from constellation diagram. Threshold is at center because threshold is in between. If both symbol are transmitted with equal probability, threshold will be in center. In PSK, threshold is lambda equals to 0. We will discuss in next lecture about threshold. And for we can summarize in a small way about ASK, FSK and PSK. ASK is OK, FSK and PSK. S1T for this is A cos omega CT. S2T is 0. S1T A cos omega C2T, C1T A cos omega C2T. S1T is A cos omega CT A cos omega minus A. Line code unipolar NRZ, polar NRZ, polar NRZ. Probability of error for this is Q root EB upon N naught. Probability of error for this is Q root EB upon N naught. Probability of error for this is Q 2 root EB upon N naught. 3 dB superior. Probability of error in term of A square T by 4 N naught. Probability of error in term of magnitude and time duration 2 N naught. Probability of error in term of A square T by N naught. Bit energy in this case A square T by 4. Bit energy in this case A square T by 2. Bit energy in this case A square T by 2. Bandwidth occupied in this case is twice RB. Minimum bandwidth for FSK, it is minimum. It might be more than this. Twice RB. Bandwidth efficiency for ASK is RB upon 2 RB is 0.5. Bandwidth efficiency for FSK is RB upon 3 RB is 1 by 3. Bandwidth efficiency for PSK is RB upon 2 RB is 0.5. That's all for this.